problem where we're actually given the solution set of an inequality. And I use this notation right here, minus 5 comma 7. That means just the open interval minus 5 less than x less than 7. Okay. All right, and that's just a shorthand way of saying that any number between minus 5 and 7 is in the solution interval. Okay, the solution set. And we're supposed to work backwards and actually find the coefficients a and b of the linear right-hand side of the inequality. Now, just to give you an idea, the approach, this looks like directly, this looks like it would be a pain to solve, but let's just use a kind of a simple concrete example of the approach here. We know that, well, I'll write it down at least. We know that consider the solution interval minus 2 3/2. And folks, this isn't a point in the plane. It is a solution interval, just like I described. Some people get that confused, but it's very context sensitive here, so it's clear the context. But minus 2 3/2 would be a solution interval. Okay, I'll just say for, let's look at, this is the solution interval for the inequality minus 3, and this is not too hard to verify, minus 3 less than 2x plus 1. Less than 4. All right, and you see that's not hard to, you can check that out yourself, but it's certainly true. Notice a real simple test would be zeros in this interval, right? Well, we certainly get that 1 is between minus 3 and 4. 1 is in this interval, and we get that 3, let's see here, let's see, 1 is contained in this interval. So right here you would have 3 is greater than negative 3 is less than 4, right? And again, just working backwards, you can see that this would be the solution interval for this inequality. And it's clear that equality occurs at these endpoints. In other words, if you take a look at both of these endpoints, they lead to equality. And that's really just the definition, really, of the solution interval in a manner of speaking. So, in other words, the endpoints imply an equality condition. Instead of less than, it would be less than or equal to, less than or equal to. So that's what we're going to do in this problem. We're just going to take advantage of that equality condition that's implied by the inequality. Okay, and so you'll notice here we're given minus 5 and 7 is the solution interval. We're defined a and b. And you can see right here, well, that's exactly what we did. We substituted minus 5 into this. We put minus 5 here, and minus 5 here, right? Now, I won't go through all the algebra with you, but when you solve, when you simplify the arithmetic here, you get this statement. When you simplify the arithmetic here, you get this statement right here, okay? Now, notice this thing is ripe. It's 2 equations, 2 unknowns. It's ripe for a subtraction to eliminate b. So if we subtract this first equation, here from this second equation, the b eliminated, and you get this statement right here. 151, 65 ninths subtracted from 151 ninths is 86 ninths. 7a minus a negative 5a gives you 12a. Okay. Now, when you solve that, you get a is equal to 43 over 54. And again, I won't bore you with the details. The arithmetic is tedious but straightforward. And so we already know that a is equal to 43 over 54. A is equal to 43 over 54. Now, if I substituted it into the smallest equation, the equation with the smallest constants, okay? And so you can see right here, I took this minus 43 over 54 and just placed it right here where a is, okay? And at that, a nice thing that happened here, just arithmetically, if you guys are interested, notice that 54 over 9 is 6 right here. 54 divided by 9. That was just kind of an arithmetic fortuitous occurrence there, but 54 over 9 is equal to 6. All right. And so that explains that made the arithmetic a little bit easier, because if you multiply through by 50, all the way through by 54, 54 over 9 is 6. 6 times 65 is the 390 that you see right here, okay? So no calculator required, but you have to pay the price of multiplying b by 54, okay? So what we end up with right here is 54b is equal to 65. And so that's going to tell us that 605 over 54, 605 divided by 54 is equal to b. You know, something that really gets my goat is how stuff always ends up italicized no matter how hard you try. You save it off, is non-italic. You guys seen that? Like, look at this, italicized b. Some about this equation editor, I love it, but it italicizes the hell out of stuff. I need to keep it from doing that. If anybody knows, let me know, please. But anyway, 605 over 54 is b, and a is equal to 43 over 54. And so those are some crazy fractions, but you can check if you come back up here and you substitute them in. Let me see, can I keep it on the same screen? 43 over 54 goes right there, and then 605 over 54 goes right there, and you actually get this clean solution interval. But note, again, I want to repeat, if you try to solve this directly without taking advantage of this equality condition, meaning that at the endpoints here, you're going to have equality, not inequality, right? For this just trivial example, it's the very same thing no matter how complex the left-hand side is, or how involved the right-hand side is. You're going to end up using the equality at the endpoints to get a simplified version of things without actually having to analyze, the two-state absolute value definition, and get into all of that. Those things can be, those type of inequalities can be difficult, in my opinion. So anyway, the equality condition is a big observation right here. And I noted this watching this video by Wei Tan. I think he's out of Singapore, and he does these reviews of the SMO Open section, senior section, junior section. And this is problem 5 from SMO Open 2023. Or it's not, it's very similar. I used some different numbers. This is very similar. They always use simple integers. I put this fraction here, which makes the computations quite a bit more challenging. But in any event, it was this idea of the simple observation about equality at the endpoints is what made the thing fly and made it a relatively straightforward problem, albeit slightly tedious. Thanks for viewing.